afternoon, everyone. I'm Lucia Copes. I'm from Argentina, and I work as detection engineer in McAfee. But don't worry, I'm not here like a vendor to talk about our product, but as a new member of the Blue Team community to talk about my experience in which we call the Blue Team and how we apply software engineering practices for the win in the mission of creating our detection and response tools.
Yeah, absolutely. And we're a multicultural team. We have people from different backgrounds, different countries, as you can see here, like Argentina and Spain represented. We have data scientists, software engineers. We have security analysts, what we would call blue teamers. But the truth is that it's hard, right, sometimes to combine a blue teamer with a software engineer and put them together to work on a security outcome, right? So that's what this talk is going to be about. And sometimes I feel like, I'm going to explain more about that, but when I joined the team 3 years ago, I felt like as if it was like a different language. I come more from a blue teaming background, and now sitting with them, it felt like it was a completely different language. Have you ever been to maybe a place, going dinner with some friends, they speak some other language, maybe German or Spanish, right, or French, and now they meet some other friends that they also speak that native language, and all of a sudden they start talking like in Spanish, right? What's going on? You feel like left out. Where's John? John Hubbard, right? We were having yesterday, right? So John Hubbard felt like that last night. We met some friends, and all of a sudden it's like, oh, you're from Puerto Rico? I'm from Spain. She's from Argentina. And then we speak Spanish, right? So to illustrate, it would be like if I say, bueno, Lucía, ¿qué tal? ¿Cómo te va? ¿Te está gustando este evento de SANS?
Sí, la verdad que estoy muy contenta de estar acá, pero admito que estoy bastante nerviosa. Yo creo que se me va a pasar cuando terminemos la charla igual.
No te preocupes, en nada que terminemos nos tomamos una cerveza y celebramos que hemos terminado.
Okay, did you understand us? If so, you can join us for that beer later on tonight. And if you didn't understand what I'm talking about, I'm sorry, you will miss that beer.
You will miss that beer, yes. Now, did you feel like that when you started to work on these security projects, blue teaming, SOC? How did you feel about it?
Okay, look, I'm a developer. So I know things like software engineering and agile practices, software quality, automation, among others. Is there any software engineer in this audience? Hands up. Okay.
Software engineers? Just one?
Yeah.
Okay.
So you will understand what I mean here. Look, as engineer, I had to learn what these strange terms mean, like blue teaming, red teaming, purple teaming. Why is not yellow teaming, maybe? Same with the defend the flag or capture the flag. Can we keep the flag alone in peace?
Yes, we should keep the flag alone in peace, right? We don't think about it, but think about talking about these terms with other people that are not coming from a blue teaming, or a cybersecurity background. It sounds awkward. Now think about my experience. I have about 20 years experience in, as I say, defending all the things, right? I started as more a penetration tester, but I've been essentially doing blue teaming for most of this time. And I know about, as you can see on the slide, right, hunting, SecOps tools, networking, forensics, and all of that. And I've done development, like about 20-something years ago, I started working doing Cold Fusion and PHP development. But it's also true that if you sit down with software engineers right now, especially if we talk about DevOps, agile methodology, it's a whole different world. So here I am sitting on this first call with a team about 3 years ago, and they start talking about epics, PSIs, PRs, stories, sprints, rituals. Rituals? What are we going to sacrifice here? The new guy? Are we going to sacrifice a goat or something? I was totally lost. And then over time, we started to work together, and that's where the whole DevBlue thing comes from. And that's what we're going to explain today, how through the use of blue teaming practices like automation, atomic red teaming automation, adversarial attack emulation, how we have been embedding these practices into the continuous development, in this case of a product, but we're going to try to extrapolate that to blue teaming practices. And how we've been doing this over time, and how software engineers as well, they have adopted some of our practices, and how we can adopt some of the software engineering practices for the win. So why is this important? Why did we choose this topic? I'm also co-author of Security 530 with Eric Conrad and Justin Henderson. And one of the things we say in this class, in Sec 530, is that automation, it's an architectural choice, right? It is part of the things we should be doing. And I think some of the speakers that came before us, right, they also talked about the importance of incorporating security into shifting left, knowing more about DevOps. There's no other way around, right? We're managing infrastructure as code these days. So we need to become more familiar with these terms. And I have to admit, from a blue teaming perspective, right, it's kind of intimidating. Anyone here in the audience, as a blue teamer, have to work on a daily basis with software engineers? Right? A few, right? Quite a few, right? So it's important that we become more and more familiar with these terms. For example, let's say that you're going threat hunting, or you're doing incident response. You find a new artifact on the network, and you realize you don't have a detection for it. What do you have to do? Obviously, now you have to work on detection content, right? It could be a rule, it could be analytics, could be, I'm not going to say artificial intelligence, right? Don't worry. And you have to create your backlog and then create those rules, but then you put them into production. And then what do you have to do? Well, hopefully you're going to measure the efficiency of those detection rules, right, that content you have created. And is that going to be a static thing? No, it's continuous, right? You have to continuously manage that. So how do you do that in an efficient way? How do you, if you have a large SOC team, you probably have SOC engineers as well, that they do this content. How updated are they, right, with the threats, the latest threats, and with adversarial emulation tactics, for example? How do you train these teams?
Absolutely. And this is exactly what this talk is about. So through practical examples, we are going to show you how we track our tasks and show our progress, how we assure the quality of our detections, how we achieve the continuous delivery, what purple team exercises we do, what our training plan is. So let's start.
Right.
So to start, let me Ismael help you with something important. Making sure that your goal of your DevBlue team are on sync with the rest of the company. And you know that GitHub nodes are not enough.
I like GitHub, but okay.
So for doing that, you have to choose an issue tracking system. In our case, we use JIRA because it's a used tool for a whole organization, and we think that it's important to keep aligned to the rest of the company to make the communication easier. So JIRA allows you to create an epic that contains the problem to be solved. The epic set up the goals of the next monthly release. And each epic is divided into stories, which are the activities or epic that each team member have to do to solve that problem. Well, these are basic concepts of Agile methodology. But it was an improvement since we started mapping our work into this issue tracking system, because it helped a lot with the communication with other teams and the upper management. So, will remind me something. Ismael, have you updated your JIRA ticket for the next sprint demo?
Okay, we'll talk about that one later. I told you I'm not good at documenting stuff.
So once you have gathered enough ideas to start developing your custom content, how do you manage it?
It's true that, as blue teamers, let's admit it, right? We're not good at documenting things. We like to play with our toys. We like to play with, our VMs, our tools, and maybe, hunting for the presence of the adversary, do these cool things. But when it comes to documenting, who really likes that? Okay, maybe that single guy at the back, right? No, it's not common. And I have to admit that, I like GitHub, but the most I would do is probably to leave some notes there. But if you have a large team and you have to, manage a big backlog of detection content, how do you efficiently do that? And GitHub is not enough, right? So maybe we're going to see some other better ways of managing this through the use of issue tracking systems.
Exactly. We as engineers think that it is so important to organize your workflow, so to clearly understand the scope of your work, to make the most of the previous research, as well as to know the available resources. And it's important too that this issue tracking system be analyzed in rituals, like Agile people like to say.
Okay, so agile rituals. All right, I'm getting this. How do you actually, if you have a backlog, right, of detection content you need to work on, SIEM rules or EDR rules, SysMon rules, how do you use this methodology, right?
Okay. Well, we focus on this matrix. I guess most of you know this already, right?
Oh, this is the first time I see this. What's this?
Okay, for you, this is a MITRE ATT&CK Matrix. For this audience, I should say that this work as a great catalog of attacks, tactics, techniques, and sub-techniques. So, well, last year we were evaluated for APT3 assessment, in which we had to cover all of these techniques. So, we had a single epic that said make content for APT3, and each developer had to upload its stories into this epic. But it was a very bad idea because that epic was open a lot of months, and it was so difficult to track the issues of each team member, control the dependencies of work, and cover every technique that we expected. So we realized that we need more granularity. So now, from here, come the second option, in which we assign the epic at level tactic and its story at level technique. But with the passage of time, we realized too that the epic has no end. This goes to the huge amounts as sub-technique that a technique can have.
Right, and that's a fair point. We realized of that early in the process that some of these techniques, as she's saying, may have a lot of sub-techniques, right? Or a lot of procedures that could be used to implement that technique. So for example, if you look at the tactic command and control, right? One of the techniques there is commonly used ports. Wow, there's a lot of things that could be in there, right? If we talked about DNS, for example, DNS tunneling, ICMP tunneling, any sort or form of HTTP-based tunneling, right? All of that will go under that technique. Mm-hmm. So if that's your goal, right, to create detection for just that technique, as you say, that's never going to end. You have to do something else.
Exactly. Let's suppose that you have to solve an epic that says detect persistent, maybe. It is possible. You can detect all the ways to do persistent in a month approximately. I don't think so.
And by the way, MITRE is going to, I think they just released a blog post a few days ago. They're going to come up with sub-techniques, right, for the matrix later on this month. That's what they're saying. It's going to be released. They're going to be working on that for a year. We actually, collaborated with them on that. And you probably realize, since you're using the matrix, that it's not granular enough, as you're saying.
Exactly. So from here come the first of 5 best practices that we are going to show you now, which are what we currently apply. So we assign the epic a level sub-technique, and each story will be specifically the detection rule that we are going to offer to the user. But you know that the sub-techniques are not uniquely identified yet. So this requires a lot of communication between all stakeholders involved in this process to keep an naming convention. And by tags, we indicate what tactics and techniques we are detecting in these rules, and now the epics are controllable. We know what we are going to offer to the users, and the epics ends in the stipulated period.
So essentially what we're doing is we map a sub-technique, right? Not techniques, but sub-techniques. We break those into different procedures or TTPs. We now map them to epics, right? And the detection rule, we're saying detection rule, but it could be any type of analytic, any type of detection content, right? Okay. That matches that sub-technique or procedure. That's a story in our agile methodology. Mm-hmm. And then you add tags. And those tags are going to be useful to see whether somebody's actively working on that detection content, right? Whether it's work in progress or it's been discarded, and you can keep track of all of that information over time. Now, is anybody implementing anything like this in the audience? Or some of you looking at some of that stuff? Okay, so that means that it's useful because most of you are not looking at this. Now, a few months ago, I think it was December or November, from Alex Teixeira, who maybe many of you in the audience know, a fellow blue teamer, very involved in the community, he came up with this blog post talking about detection as code. right? We've talked about infrastructure as code. Here's detection content as code. And he talks about how to build detection engineering, right? Or how to use detection engineering using JIRA workflows. So it's like, okay, we're onto something here, right? We've been doing this for a while. Some other blue teamers are also coming up with similar ideas. It means that this works, and it's something useful. What Alex Teixeira wrote about in this blog post, you have the link there, is that you have, obviously, to have a process first, right? Don't go to the tool first. Come up with your own process to create and manage detection content. Now, based on this process, you go and you build your workflow on the tool of choice. And we're using JIRA as an example here because that's what we use, right, internally across the business. But what we're saying is you probably want to use whatever your business uses. Right? Don't create some other tool, leverage whatever issue tracking system you have internally. It could be Redmine, could be anything else. And he says once you have the workflow, the beautiful thing is that now the, let's say the detection engineers, they're going to create a SIM rule, a Sysmon rule, an IDS rule. They cannot take shortcuts. They have to follow the process, right? And the process could look like something like this. You have, for instance, something that is a backlog, right? A backlog of rules, things you have to work on as a result of your threat hunting activities or as a result of incident response, or maybe intelligence that you have received, and you want to build content based on that. So from that point, right, your backlog, you can now prioritize the ones that you want to put into production, right? You shortlist them. At that point, maybe you may decide, well, some of these are going to be discarded. These don't make sense anymore. You're going to prototype them. You're going to put them into development. They're going to be tested. I'm going to talk more about the testing process. Peer-reviewed, maybe, right? There's going to be documentation, because remember, you can't skip that workflow. You have to follow it, and then eventually it's going to be put into production. So these tags can also be very useful to see the status. Right? We see green means it's done, either into production or discarded. Blue means it's work in progress. And one of the beautiful things about this use of engineering, detection engineering, is that you can create visualizations that are very useful for management. And not only for management, but also internally to track progress and see how efficient this process is. For example, we have a Kanban board and where we can see all of our backlog. Now we get together into these meetings. I love that. I'm going to adopt these rituals, right?
Exactly.
Isn't it?
Yeah.
A ritual meeting, right? And now you're going to get together. You're going to analyze, do I have enough resources to deal with this backlog? Well, if you don't, maybe that's something you can go into management with, right? Hey, look at my backlog. We need more resources. We can't deal with this. Now you're going to prioritize. You're going to put them into production. Right? You can obtain meaningful metrics by doing this this way. So that's something really, really helpful. Now, talking about visualization, is there something else we can show to management in terms of metrics that would show value?
Yeah, sure. Look, you know that managers really like charts. So it could be a good way to show your progress. We see roughly which techniques we are detecting, and we color up according to the degree of work. Okay, so first of all, by the way, this does not represent, as we say on the slide, any coverage in the product that we're working on today. It's just for illustration purposes. But since we're talking about coverage, just because a cell in that matrix is showing green, which, by the way, you can do this with Attack Navigator. Right? You guys familiar with Attack Navigator? You can import JSON files, export JSON. You can have layers and say, what's the coverage that I have for this APT group, right, or for this? Now, it's great, but what does coverage mean in this context? If it's showing green, does it mean that you're good? So assuming that you manage to have the matrix with green all over the matrix, are you doing great, right? Pat yourself on the back, don't do anything else. No, because as we said before, each of these techniques could have sub-techniques, and you will never be completely sure of how many sub-techniques attackers can use, right, to implement these techniques and tactics. So the key here is the quality. So how do we ensure quality when we create this detection content? Okay. Well, with the passage of time, we became stricter in what we have to do about product development. So we know that creating detection rules is not enough. we have to guarantee that the rule behaves as expected with precision and avoiding false positives or false negatives. So we organize the product quality on 3 levels. Well, the first levels include the pull request. So each time a developer attempts to integrate new content into the repository, a series of tests are run to guarantee its quality. So the unit tests control the syntax of the rule. The atomic test simulates a step of the attack that should be detected by the rule, verifying its semantics. And the replay test control the behavior of the rule through a huge amount of traces that we have.
So now to draw like a parallel in the blue teaming world, right? This is the agile practice at pull request level. If you have, for instance, you're creating an IDS rule, right? Snore, Suricata, whatever, or a Zig script, for example. How do you test the efficiency of that? Well, you may have a collection, let's say, of pcaps, right? A binary file that collects all these packet traces, and you could just like re-inject this on an interface, maybe with TCP replay, right? Re-inject those packets, and now you figure out, okay, these rules that I have are efficient or not. Maybe I have a high number of false positives, I need to tune that. Well, that's exactly the same thing we do here, right? Replaying traces in this case, meaning activity that we extract from the endpoints, right, for an EDR product, but replaying that at this level to do a first quality check.
Exactly. So at second level, at build level, we have the automated execution of atomic tests that consists of more than 500 tests, in which some of them were done by McAfee members and another were taken by external and worldwide recognized sources, but customized to our needs. So this and the entire unit test suite are run again. So on the other hand, we have the goodware suite, which consists in an installation of so many programs that we know are reliable and should not hit the rules, also verifying the semantics. And finally, a report is generated that informs the result of the previous execution.
So again, to draw a parallel with the blue teaming, right, world. For instance, if you have to come up with a JIRA rule, right? Let's say you want to use a pattern matching engine, like JIRA rules, to find specific malware where there's these specific strings. Now, you know that can trigger a lot of false positives, right? If the quality of the rule is not good, how do you test that? Well, you're not going to only run that JIRA rule against malware samples. What else are you going to do? You want to run this against a set of goodware, right? Binaries that are known good, that you know that they should not trigger an alert, right? They should not match that rule. So that's essentially what we're doing here. So think about how you could adopt this practice. For example, you're writing Sysmon rules, right? Or you have an EDR allows you to write some content. How do you test that there's not a high number of false positives? As Lucia said, something we do, for example, is use installers. So you can get a bunch of installers that are legitimate, right? Things that users are going to do on a regular basis on their systems, and then run them. Now, what does an installer do? Usually it creates a lot of noise, right? It's going to do a lot of file disk activity, a lot of registry changes, and lots of things are going to happen in that system in a short period of time. Now, is that malicious activity? No, in this case, it's just goodware, right? So this is, again, something you can do, you can build in your detection engineering cycle to make sure that the quality of the rules or the content you create is good.
Yeah. And on the third level, at release level, so when the release to production was carried out, we ran a smoke test in which we guarantee the integrity of the product end-to-end, and we communicate the result of the release to the market to all the stakeholders involved with what features we are added or modification were integrated in the build.
Okay, so hold on a second. So rituals and smoke test? I see where this is going. Is this some sort of Argentinian asado thing or barbecue, right? We're here in Kentucky. What's going on?
No, I love the asado, but no. The smoke test is a quick review in which you guarantee that the product works and has no defect that interrupt the basic operation. Right. It's an important review after it changed.
Okay, so every change, right, we make sure the integrity, right, of the product.
Exactly.
Okay, that's great. So that's something, again, that we can learn from and we can adopt, right, as blue teamers in the SOC. Now, let's assume that I'm doing all of these things, right, at these different levels, and I do the first checks, I do all of this automation, right, with things like atomic red teaming or, Caldera, APT simulator, and of course, these are open source projects. You can modify them, right? You can go into the code and modify them, customize them to your environment. You run all these things, you're good. Now, how early would I see the benefits of doing this in terms of like quality, right? You're doing this on a regular basis now. How far into the process do you have to go to see the improvement in quality?
Okay. We think that it's extremely important to provide our customers with continuous delivery. Our team prefers this approach in which we develop content in short cycles because short cycles means less risk and more control. We think that smaller and frequent increments are better than big sporadic changes. So to get the continuous delivery in a controlled way, we organize that process into our EDR content release flow.
Okay, so I guess this is the whole core of Agile, right? Like going through this cycle. Now, let's imagine I have my SIM rules, they're ready, I want to put them into production, right? What's next? How do I go over this cycle?
Okay, after the push, you have to inspect the rules behavior. So for doing that, you have to find your key indicators and keep them controlled. In our case, these are noisy rules, rules with high severity, detection rules, among others. And it's useful too that you organize the key indicators into dashboards like this to clearly visualize the information. And if you detect something different as you expected, you have to adapt the rules. So for doing that, it could be useful too that you have an environment to test to control your changes. And once the rules are validated, you are ready to push. And remember that cadence is everything.
Okay, so what does cadence mean in this context? So we can, like blue teamers, we can understand.
Okay, cadence is something like you do. Inspect and adapt is at the core of what we do. It's not something sporadic, like updating our JIRA tickets.
Like me updating my JIRA tickets, right? Okay,
Exactly.
I got it. So imagine you're doing all of these things, right? And we said automation, it's key, right? Automating these tests, ensuring the quality of the process. Now, that makes me think as a blue teamer, that's great, but I know that that's not how attackers work, right? And we learned from Paul Melson yesterday as well, talking about these adversaries, cyber criminals. Sometimes we may think they just push a button, that's all they do, right? But usually it takes a bit more. And that's why when we talk about purple teaming, we're really talking about adversarial emulation, which means you're finding a human, you need another human brain that's doing this. So we've incorporated this into this software development lifecycle, but more importantly into the detection content engineering, right? And that's one more best practice that we want to share with you, how you can do this in a practical way, right? If you're detecting new rules, new content, make this an essential part of testing the quality of your content, purple teaming. And I can say, we've even, and I'm part of the team that actually developed the roadmaps for these, for the organization, for these products. We defined a whole roadmap based on different adversaries, right, different threat models. And of course, we have our own internal red teamers. I've been doing this for many years as well, and I help the team conducting these exercises. But we also benefit from having external people come in maybe once a quarter to show us, it could be a tool that they created, right? It could be like some way of implementing one of these techniques, a sub-technique that is like, oh, no, that's interesting. I never thought you could do it that way, right? So that brings a bit of it spices up a little bit the process, and it sparks some creativity into the team, and it makes you think in a different way, which is great. Now, I know that you've been part of some of these purple teaming exercises.
Yeah.
If you had to highlight something from this, what would it be from your experience?
Okay, I think that it's extremely important to keep engineering in the loop. So you have to share knowledge with the team so they know what to configure, what to improve, what new feature to add at the time of the audit. and it's important to that this team interacts with the UI of the product.
That's very interesting. And it's been a game changer for us. Now, I know most of you are not building products, right, or security products. You might be building other products. But think about how you can adopt this practice. Something that I've learned doing this for the last 3 years with software engineering teams is that it adds a lot of value, as you say, right? The engineers now, they get to see, oh, so this is how these rules are going to be used, right? This is the security outcome. This is the value that you're getting out of this content that I'm developing. And maybe for some of you guys that work out of larger SOCs, you have an engineering team that they're working for the SOC, right? And they're building these rules for you, the SIEM rules, the EDR rules, or the IPS rules. And we found beneficial also bringing people from management, right? So they can sit there and see, right? And I would, for instance, in many cases, I would play the red team, and I have, I'm having 2 monitors. I'm doing the red teaming with a Cobalt Stripe, with a, whatever the tool is, Metasploit, Empire. And now you have the blue team, and there's also a manager. There's maybe somebody from IT. And now they start looking at the attacks. And it's like, that's it, right? I thought it was more difficult, or I thought it would take longer. Right? So they may get surprised, and they get now context out of these exercises. Having people from IT sometimes is beneficial as well to figure out issues that could come up during the testing. Maybe there's a payload that is not working, right? A reverse shell. It's like, oh yeah, but we have this proxy or this IPS, right, that is blocking some content. Or this feature that's still enabled on the endpoint that it's blocking stuff, right? So there's definitely a benefit in having all of these things. And one of those benefits has to do with skills, right? So we're using now this as part of training plans, career development plans, and actually on the training side, we're doing quite a few fun things, right?
Yeah, sure. So we know we are not conformists. We are always trying to be better than blue teammates, and that is why we are constantly training. We use sources of knowledge like our SOC, customer calls, SANS courses, our own research, and we are always looking for new ones.
So again, with this idea in mind, right, the people that are helping you out to develop content for the team, those rules, get them to experience what the day of life of a SOC analyst looks like, right? Sit with them, sit on some of those calls. Lucia, I think you're taking a SANS class, right, after this one?
Yeah.
After the summit?
Yeah.
Awesome.
I do.
And something that I've been working on personally for the last year, and you guys are familiar with that, and if you're not, you may have a chance to play that this week, right, at this event, some of the classes. Networks. Networks is amazing. So, I was involved last year in preparing a Defend the Flag competition. We do a lot of those within an organization, more like CTF-oriented, right? We've done a lot of those at Black Hat and other places. But this was the first time we built a Defend the Flag competition, a blue teaming competition, using our own products. And my goal with doing that was actually to give it to the engineers so they could play the game with the product that they're developing, right? And the outcome of that has been awesome, right? Maybe you can explain a little bit, how did you feel about that? How do you like it?
It was so fun, and it helped me to understand the practical value of our detection content for the customers. Right. Oh, and I won that coin.
Oh, you won the coin. Awesome. I also have a sticker, so if you want one, you pick me after the talk. But that's awesome, and it actually shows that there is no substitution to actually doing the job, right? And these Defend the Flag competitions help you a lot with that. So to summarize, we've talked about a few things. You have the key takeaways there. We're not going to read those. But from your personal experience as a software engineer, what did you extract out of this process?
Look, when I started in McAfee as a detection engineer doing quality assurance, I thought my goal was to find bugs. But through the applying blue team practices, I had the chance to learn a lot of things about cybersecurity topics or security outcomes, and that is now my main motivation. That's
awesome. And I have to say that it's great to hear that from you. I've also heard that from a lot of other people that they started as software engineers, they're working on just one more product. And now it's like through these training exercises, Defend the Flag things, they started to realize like, wow, I really want to have a a career, as a blue teamer in cybersecurity, and that's awesome, right? It makes helping to make blue great. All right, so any final thoughts?
So remember, apply software engineer practices for your win. Thank you.
Any questions?